Hello students, welcome back to the Tantra Sir Physics classes. Today's lecture is 7th lecture or today we will discuss escape velocity from the surface of the earth. अगर हमें कोई ऑब्जेक्ट सरफेस ऑफ द अर्थ से थ्रो करना है into the space so that it does not come back, it should cross the gravitational field of the earth and should stay there, maybe at rest, but it should cross the gravitational space. What is the minimum velocity which should be given to the object so that it crosses the gravitational field? And that minimum velocity is called escape velocity. The minimum velocity given to the object from the earth's surface so that it crosses the gravitational field of the earth and does not come back. But by the time it reaches there, crossing the gravitational field of the earth, there it remains at rest. So we have to give only that much of velocity which will make it to escape. अगर इसको वहां भी कुछ वेलोसिटी चाहिए, ग्रेविटेशनल फील्ड को क्रॉस करने के बाद भी कुछ वेलोसिटी चाहिए, तो हमें यहाँ वेलोसिटी को एस्केप वेलोसिटी से ज्यादा वेलोसिटी देना पड़ेगा. बट हियर I want to tell you, I want to explain how much velocity we need to give to this object so that it crosses the gravitational field of the earth, it never comes back. Maybe the object will remain at rest there when it crosses the field. So that is the concept. First of all, when the object becomes free of any force, free of any influence, the answer is when its total energy is zero. When the energy of the object becomes zero, the object becomes free. My energy is negative. That's why I am bound to the earth. अगर मेरा energy zero होता तो मैं float कर रहा होता, मैं free बन रहा होता. I would have been free if my energy is zero. But my energy is negative due to gravitational field of the earth. That's why I am bound to the earth. So what we have to do, ये जो object यहाँ है, हमें किसी तरीके से इसका energy zero बनाना है. अगर हमने इसका एनर्जी जीरो बनाया, ये फ्री हो जाएगा. इट विल क्रॉस द ग्रेविटेशनल फील्ड एंड स्टे देयर. सो तो एस्केप वेलोसिटी का डेफिनेशन ये है, इट इज द मिनिमम वेलोसिटी दैट शुड बी गिवन टू द ऑब्जेक्ट फ्रॉम द सरफेस ऑफ द अर्थ so that it crosses the gravitational field of the earth and stays there. That is, it will not come back. That's all. So how to find the escape velocity? So first of all, जो object surface of the earth पर है, उसका potential energy कितना है? The potential energy of the object here on the surface of the earth is minus g capital M small m by r. This is the potential energy of the object on the surface of the earth, due to which it is bound. It is bound to the earth's surface because of this negative energy. What I will give to it, I will give it kinetic energy. I will make it plus 1 by 2 mv escape square, where v is the escape velocity. दोनों जब मिलेंगे, नेगेटिव क्वांटिटी एंड पॉजिटिव क्वांटिटी, it should become zero. That's all. When it becomes zero, that means it will cross the gravitational field of the earth. And finally when it crosses there at infinity, its potential energy is zero, its kinetic energy is also zero, but total energy is again there zero, because energy has to be conserved. Initial energy was zero by adding this kinetic energy, and finally the energy will also be zero, but by then it will cross the gravitational field of the earth. Okay, so when the total energy becomes zero, because when the energy of the object becomes zero, it becomes free. That is the concept. We have to add positive energy to the object which was having already negative energy. दोनों energy मिलकर जब ये zero energy बनाएगा, total में zero होगा, तो it will be a free object. It will never come back. So इसको solve करने से m और m cancel हुआ, तो ये v escape square by 2 is equal to gm by r. तो v escape किसके बराबर होगा? v escape is equal to यहाँ चला जाएगा रूट सेकंड साइड से 2gm by r. So this is the answer to the question. This is the escape velocity. और g, m और r अगर सबस्टिट्यूट आप करोगे अच्छी तरह से, तो it will become 11.2 kilometers per second. It's a huge velocity that you need to give. 11 kilometers, और वो भी 1 सेकंड में चलना चाहिए ये initially when you throw the object upwards. 11 kilometers per second is a huge velocity. So it is not easy to escape the objects, to project the objects to infinity. Not easy unless you use rockets and boosters to launch an object to the infinite distance, so that it crosses the gravitational field of the Earth. Basically, the 11.2 kilometer per second is a very huge velocity. To give an object this much of velocity, we need technical support. Okay, so this is the escape velocity of an object. लेकिन जब हम इस चीज को देखते हैं यहाँ पर, इस इक्वेशन को, यहाँ पर g है, कैपिटल M है, R है, मास ऑफ द ऑब्जेक्ट नहीं है, तो इसका मतलब ये है चाहे आप स्मॉल ऑब्जेक्ट को लॉन्च करना चाहो या बड़े ऑब्जेक्ट को लॉन्च करना चाहो जिसका मास कम हो या ज्यादा हो, तो एस्केप वेलोसिटी मास ऑफ द ऑब्जेक्ट पर डिपेंड नहीं करता है. तो एस्केप वेलोसिटी मैं यहां पर लिखना चाहूंगा, एस्केप वेलोसिटी neither depends on mass of the object nor on direction of propagation. Propagation या डायरेक्शन ऑफ लॉन्च. मतलब जब ऑब्जेक्ट को हम लॉन्च करते हैं तो एस्केप वेलोसिटी ना इसके मास पर डिपेंड करता है, चाहे उसको छोटा ऑब्जेक्ट हो या बड़ा ऑब्जेक्ट हो, उस पर डिपेंड करेगा नहीं, ना ये डिपेंड करता है द डायरेक्शन ऑफ प्रोपेगेशन. चाहे ऐसे लगाओ यूं, चाहे ऐसे लगाओ, चाहे ऐसे लगाओ, ऐसे लगाओ कि तो इट विल हिट द ग्राउंड, लेकिन बाकी डायरेक्शन में आप कोई भी डायरेक्शन ले लो, it will escape the gravitational field of the Earth, because the equation says that it neither depends on mass nor direction. Okay, this is one part. This is one part. Second part. Now we have a second part is, if we want to launch an object not from the surface of the Earth, we want to launch it from certain height. ऑब्जेक्ट पहले ही भागा हुआ है ना किसी हाइट पर, तो हम इसको यहां से लॉन्च करना चाहते हैं. Maybe it is a satellite and we want to knock off the satellite to infinity. So already satellite is moving around the Earth in some orbit, और उसको destroy करना चाहते हैं, उसी को infinity में knock off करना चाहते हैं. So that is where we want to launch an object from certain height. So what will be the escape velocity in that case? Escape velocity in that case will be root of E g E m 2 times, जो पहले निकला. लेकिन नीचे आर था ना, नीचे अभी जो हमने सरफेस से लॉन्च किया उसमें आर था, कैपिटल आर, रेडियस ऑफ द अर्थ. अब इसमें आर प्लस एच लिखना पड़ेगा, दैट इज ऑल. तो ये एस्केप वेलोसिटी जो है, अगर प्राइम करूंगा मैं तो सीधी सी बात है, प्राइम इज लेस देन वी. ये एस्केप वेलोसिटी कम होगा उस एस्केप वेलोसिटी से जो आप ऑब्जेक्ट को अर्थ से लॉन्च करेंगे. ऑब्वियसली इट इज डिफिकल्ट टू लॉन्च द ऑब्जेक्ट फ्रॉम अर्थ देन टू लॉन्च इट फ्रॉम सर्टेन हाइट, क्योंकि सर्टेन हाइट तो वहां ग्रेविटी का इफेक्ट कम होता है, तो वहां से लॉन्च करना इन्फिनिटी को, that needs less escape velocity. So that was second part, if you want to launch an object from certain height. Third part is, you see, suppose we have an object at the center of the Earth, hypothetically, although we never do that, we don't launch the things from inside the Earth. We launch the objects either from the surface of the Earth or from certain height. But hypothetically, let me suppose that the object is at the center of the Earth, or any object is at the center of Earth of some shape. We want to launch it to the infinity. It is quite hypothetical, but students can be asked such a question also. As object is at the center and I want to throw it from the center into the free space. I want to make it escape the gravitational field of the Earth away. So what should I do? So for that, object is here of mass m, I want to launch it to the infinity. So how much velocity I need to give it? First of all, I must know what is the potential energy of the object at the center of the Earth. The potential energy of the object at the center of the Earth is G minus 3 by 2 Gm small m by R. That I have already discussed with you what is the potential at the center of the Earth, what is the potential energy of the object at the center of the Earth. That we have already done. Plus, it was the potential energy, right? But I have to add kinetic energy to it. so that total energy becomes zero and it escapes. Because once the total energy of the object becomes zero, it is free. Somehow you make the total energy of the object zero. So plus 1 by 2 mv escape square is equal to 0. You have added kinetic energy to the potential energy, so that the object energy becomes 0 and the object will go into the space. It will never come back. It will go to infinity. It will never come back because it has crossed the gravitational field of the earth. Okay, now let me do it from here. M gets cancelled. 1 by 2 v escape square is equal to ले जाओ 3 by 2 gm by r. So what is v escape? 2 and 2 cancels. V is equal to root of 3 gm by r. और अगर इसको एक्सेलरेशन ड्यू टू ग्रेविटी में लाया जाए, यहां पर सरफेस के एक्सेलरेशन ड्यू टू ग्रेविटी में लाया जाए, तो r को मल्टीप्लाई वो डिवाइड भी, इट विल बिकम 3gr और सरफेस का उस हिसाब से मिलेगा आपको 2gr एस्केप वेलोसिटी फ्रॉम द सरफेस ऑफ द अर्थ. तो दिस इज द एस्केप वेलोसिटी if you want to launch the object from the center of the earth. Also, you see here, it is slightly greater than the escape velocity from the surface of the earth. Because आपको डीपर से लॉन्च करना पड़ेगा, तो ये एस्केप वेलोसिटी अगर अर्थ के सरफेस से लॉन्च करोगे तो वो एस्केप वेलोसिटी और ये एस्केप वेलोसिटी डिफरेंस तो है. मतलब ये एस्केप वेलोसिटी जो है, जो सेंटर से लॉन्च करोगे वो ज्यादा होगा, क्योंकि आफ्टर ऑल यू आर गेटिंग इट फ्रॉम डीपर इनसाइड. तो ऑब्वियसली फ्रॉम द कॉमन सेंस आल्सो द एस्केप वेलोसिटी ऑफ दिस ऑब्जेक्ट शुड बी मोर. तो हमें निकला भी 3gm by r. सो एस्केप वेलोसिटी फ्रॉम द सेंटर, चलो इसको मैं फ्रॉम द सेंटर ऑफ द अर्थ, सेंटर ऑफ द अर्थ is greater than escape velocity from the surface of the earth. Escape velocity from surface of the earth. So you can substitute these values and get some numerical value. I don't remember the numerical value of this, but you can substitute 3g and r, and the numerical value will be slightly greater than 11.2 kilometer per second. So this was the lecture on escape velocity of this objects. Or you can apply the same rule, escape velocity of the satellite revolving around the earth. उसको escape करने के लिए कितना velocity आपको देना पड़ेगा? That is already having some orbital velocity, and you need to give some additional velocity so that it escapes the gravitational field of the earth. So, but the point is that you need to remember. You need to remember what is the potential energy of the object on the surface of the earth, at the center of the earth. तो वो आपको देखना पड़ेगा. तो फिर आपको उसके बाद आपको काइनेटिक एनर्जी ऐड करके उसको जीरो बनाना है, तो द ऑब्जेक्ट एस्केप्स. और एस्केप वेलोसिटी सिर्फ ऑब्जेक्ट इन्फिनिटी को जाकर के वहां रेस्ट में रहेगा. अगर आपको इन्फिनिटी में जाकर इसको वहां भी वेलोसिटी चाहिए, तब जाकर आपको ऑब्जेक्ट को एस्केप वेलोसिटी से ज्यादा वेलोसिटी लॉन्च करना पड़ेगा, so that it crosses the field and then it has additional velocity from there onwards. So this was the 7th lecture on gravitation. It will continue for some more days, so that the gravitational chapter is completed. And don't forget to watch the lectures on the YouTube. I will be continuously delivering lectures for you so that you get benefited. Thank you.